Okay, so Unit 2 is all going to be about rates of change. So we have three objectives. We're going to find the average velocity on an interval, the instantaneous velocity at a point, and calculate rates of change in applied context. So the first thing you need to realize, we'll be revisiting, it's called motion, throughout this year. So some standard notation applies. So they let S, we don't use F for our function, so they let S be our position function, okay? So S is our position. And it's T, it's S of T. If the object changes over a period of time, then that triangle is called delta, which means change. So the change in time is called the average velocity. And it is given by the formula, the change in S divided by the change in T, which the change in S stands for change in position and change in time. So what you have to remember is change usually means the difference. So let's look at our first example. So when we've got S of, we'll just let this be B, S of A all over B minus A. Our tennis ball is being dropped from a height of 100 feet. Its height is given by this position function. So this 100, that's where it shows up. So we really don't need to know that, but that's where it came from. Due to gravity, this is a common number that you'll see. So this is our position equation. It's like S of T, if you want to think of it that way. We're measuring it in feet and in seconds. You won't be converting, that's not our issue. So we want to find the average velocity over 1 to 2. So these are time values. So like 1 second and 2 seconds, okay? So we've got S of 2, S of 1, all over 2 minus 1. So we're really just, it's a slope formula. We're going to plug in 2. So 2 squared is 4. 4 times 16 is negative 64. Negative 64 plus 100. I'm sorry, minus, yeah, plus 100 is 36. Then we'll plug in 1. Negative 16 plus 100 all over 2 minus 1. So 36 minus 84 is negative 48. And our label is feet per second. Okay, so that's our application. The average velocity in the first example is negative. That indicates that the tennis ball is moving down. So I don't call that speed. Velocity is not the same thing as speed. The relationship is speed is equal to the absolute value of velocity. Velocity, I think of it this way, is, that's a Y, is your signed speed. It shows direction. Okay? It shows direction and speed, really. So when you get a negative answer, you're like, oh, wait a second, how can I have a negative speed? Well, that's not what velocity really is. Okay, so let's look at our next example. We have a table of values given, and we're talking about a particle moving along the x-axis. So kind of think of this as a number line. These are the position, this is where they are, so it looks like we're moving up and up and up or to the right. Approximate the average velocity when the particle equals 5. So we have to think, well, wait, I don't have 5 here. How am I going to, and that's why it says approximate, because we can't find the exact. So if I want to use the estimation for 5, I need to choose an interval that has 5 between it. So technically I could use 1 to 9. But the more precise you are, the more accurate your approximation is going to be. So we're going to use between 4 and 6. Okay? Because 5 will be in between there. So it will approximate it. It's just not going to be exact. So we've got our x of 6, because they're letting x be our function. We just go with whatever notation they use. So this is average velocity. X of 6 is 20, so they're giving us our values. X of 4 is 13. I want you to start getting used to writing your notation, because when we do our free response questions, this is what you get points for. So the better you are writing your notation and not just the answer, the more points you get. 20 minus 3. And you can leave fractions. Don't reduce it. If you do make an error reducing, because it's minor arithmetic, you don't lose points, but there's no need to. Fractions are great. All right, so now let's talk about position versus velocity. So if you are given a graph, as you decrease the interval used to find the average velocity, then as our points get smaller and smaller, like if we go from 1 to 4, and then we go from 2 to 3, and what if we could go for like 2.4 to 2.5, and then 2.49999 to 2.500001. Well, as we get closer and closer and closer together, it's almost at 1 point, so we call that instantaneous velocity versus average velocity. So the notation is this, it's our limit, and we want that change, the distance between the two time values, to get closer and closer and closer to nothing. We want them to be almost on top of each other. So like they kind of illustrated it with these lines. So we went further away, we got closer, and we're getting closer and closer and closer. If we use, this is our average velocity formula, S of our first value minus S of our second value all over the change in t, then it's going to equal what's known as S prime of t. Now, S prime, this is a new notation, okay? That's also the same as velocity, okay? A velocity function. Remember, our original function, S of t, is position. So now we're saying that S prime of t, which is also known as velocity, is our second function that we'll be talking about. In other words, the velocity is this is called the derivative. The symbol is called prime, but this is now going to be known as a derivative of the position function. So they're not the same. Velocity is a vector, which means it has direction. Velocity can be positive, negative, or zero. Speed is the absolute value of velocity and cannot be negative. So I talked about that on the last slide. We just got ahead of myself. I always do. All right, so let's look at example number 1. So at time t equals 0, we have a diver jumping from a platform. It's 32 feet above the water. That's why you see this 32. The position of the diver. So this is my original function, okay? That's what I kind of keep in mind because it's position. So that's our original function, S. S is in feet, T is in seconds. Pretty common. Well, when does the diver hit the water? So we have to think, well, when would a diver hit the water? Well, if you hit the water, it means that my height is 0, which height is your position. And so I want to know, when does S of t equal 0? And believe it or not, if this was a free response question, you'd get 1 point just for knowing that that's the relationship that you need, even if you couldn't find it. Okay? So I actually need to solve this though. So we'll set our function, and if you change these to x's, that's okay. You won't be marked incorrect. I'm going to divide everything by negative 16. So t squared divided by negative 16, negative 16. This factors t. We've got 2 times 1. To get negative 1, I need negative 2 and positive. Zero product property. Okay, so let's talk about something. We have time is equal to 2 seconds and negative 1 second. Now, depending on the case, we could have something like if I started at 5 minutes and I had negative 1, then that would be 1 minute before. But we're talking about time equals 0. So this is not going to be possible in our context. We don't always automatically rule that out, so we have to look at some of the conditions. So 2 seconds is when the diver hits the water.